So while Rohin is setting up, let me introduce him. So it's my pleasure to introduce Rohin Parker. Rohin Parker is the co-founder and CEO of Spintly. Spintly is an access control company developing wireless mesh-based solutions for access control solutions. Rohin has a background in RF engineering, and he's worked with many wireless companies such as Motorola, Nokia, and Broadcom. He also has a lot of technology experience in various wireless technologies, whether it's cellular technologies starting from 2G all the way to 5G, Wi-Fi, and Bluetooth. Rohin started Spintly in 2018, and they launched product powered by Bluetooth LE mesh-based technology. Over the last 1 year, they've been active on support, adding thread support in all of their products. Their Spintly is the latest winner of the Thread Enabler Award. Congratulations, Rohin, and take it away.
So thanks for the opportunity to speak at this event. I'm really happy to be presenting to the entire group. And obviously, I'll repeat the same thing in person. And really happy to be recognized for the work which we've done through the award, Thread Group Enabler Award. So I'm going to talk about access control more than building automation. We are an access control company, and we feel that building automation and access control, all the silos are going to come together one day. So hence the topic building automation. A little bit about our company before I jump into access control. So we are an access control company established in 2018. We launched a fully wireless access control solution in 2019. And we started our business in India, started acquiring customers in India. We added support for Thread in late 2021. I'll talk about how we moved from having support for Bluetooth mesh to Thread during my presentation. We won the award for Thread Enabler, the Thread Enabler Award, which was in February 2022. And now we have started expanding our market in the North America region. So how are we related to building automation? So any building consists of various systems, including access control, lighting, HVAC, and all the other systems. We are focused on access control, majorly focused on smartphone-based door access. That has been our entry point into the market where we are enabling smartphone access. But our key differentiator is the wireless mode of communication between the access control readers. And we believe that in a building, devices, irrespective of their application, they will talk to each other. Right? So whether it's access control readers or lights or temperature sensors. And that is what Thread allows. And that was our vision from day one. And we were looking for a standard which would allow us to further our vision. Right? And Thread really came in at the right time for us to jump on the protocol. Let's look at what currently buildings do when it comes to automation. Typically, this is what an entire building would look like. And you have different systems which operate in silos. You'll have lighting control systems where you have a lighting panel and you have various luminaires which are then connected to the control panel, either over DALI or analog or whatever interfaces, right? Typically, they're analog or digital. In HVAC, again, you have a controller and you have your temperature sensors and other devices you're connected to the controller. In access control, again, there is a controller and you have readers, which typically talk over a protocol called vegan protocol, and off late, a new protocol called OSDP. Again, these are wired standards. Vegan is a 2-wire interface. I don't know how many of you have heard of vegan before as a protocol? Just one. Two. Yeah, so I was surprised when I learned about the vegan protocol. It is a 2-wire protocol which just has D0, D1, and one for bit 1 and one for bit 0s. The way it works, I was really surprised. It dates back probably a few decades ago when it was developed, right? And that's how readers talk to controllers. Similar is the situation in fire alarms where you have controllers. So one theme which is common is this, all these systems are central controller based. So that's the common theme. They may have a IP backend from the controller and above, but nothing which goes down up to device level. So devices don't traditionally have an IP address in the old systems, right? So that is what we observed when we entered the market. And what this results in is huge amount of infrastructure in buildings. Room full of controllers. This is just showing access control panels in a building automation room. This is showing fire panels in a building automation room. The amount of space which gets consumed and the amount of wiring which you have to run from these panels to the devices and devices is huge. And this keeps going on and on as we build more buildings. And that is a problem we started to try to address just in the access control space. What would make sense if you were to come on a whiteboard and start drawing a brand new system for building automation? What would make sense? And that is what I'm going to put here. We believe that a distributed network of devices would make sense. Devices which could just talk to each other interoperably on the same language. And devices should be able to make their own decisions when certain things happen. For example, when a smoke detector detects smoke, it should be able to tell doors to unlock, right? And that's what the function of smoke detectors is. It should tell a fire alarm to make sound, and it should tell specific doors to unlock. And currently that happens through panels, right? Fire panels connected to access control panels over RS485, and you do round tripping of information. Whereas it could just happen over a mesh network of devices talking to each other. And a gateway device, which will always be needed in the building for connectivity to the cloud, and also to make certain edge processing for use cases which needs additional processing where the end devices cannot do the required processing. For user experience, the processing can be at the edge node. For example, in access control, the door has to open immediately when you present your card. The decision can be made right at the device level. Right? So this is what we envisioned when we started looking at a wireless platform for building automation or access control. The benefits of such an approach is obviously huge cost savings, because you're not laying down wires. You don't have controllers which are sitting in the building automation rooms, and the labor associated with the wires, right? And they are easy to deploy because these devices will have connectivity which can talk to smartphones. Like it will have Bluetooth connectivity or Thread, which can again do Bluetooth for commissioning purposes. So when you are installing a device, you can use your smartphone to commission it right there instead of going to a building automation room, pulling up a software and trying to provision the devices. So it's much more intuitive to provision such devices. So we started off with this as a concept for building automation, and we applied it to access control. And we started looking at what are the problems in access control. And the access control field had exactly the same problems which are there in building automation. Huge amount of hardware, almost 70% of the cost was going in wiring, controllers, and labor associated with it. Right? And we basically said that this can be a completely distributed system where readers have connectivity right at the device level, and they can do the job of authenticating users right there at the door. And so we built a network of wireless mesh readers which can talk to each other over Bluetooth mesh we started with, and now we added support for Thread for our readers, and a gateway device which connects to the cloud, and a fully web-based cloud-based system for access control. Right? So how did we go about implementing this? So I'll a little bit talk about what traditional access control systems look like and how they work to start with. So this is what a traditional access control in any building looks like. Everybody uses a badge. You swipe on the reader and the door opens for you, right? What really happens in the back end is the reader reads a ID, which is a card ID, which is 26-bit vegan code, which is just sent over the vegan interface to the controller. It's a one-directional interface. It can just send IDs to the controller. The controller receives it. It compares it with the database. If you're there, it clicks a relay. There is a relay on the controller which clicks, and the relay is connected back to the lock, which is on the door. So we're running two, you're doing a home run back to the controller and another wire going to the relay. Right? And the relay unlocks the door, basically. So if you have multiple doors, you're running cables to the controller and back to every door for unlocking the door. Right? And if you have multiple doors, you are actually putting multiple controllers, because every controller will support like 4 doors. So if you have 100 doors, you fill up a room with controllers, right? And this is how it works. So let's say if you were to simplify this into a wireless system, what would you do, right? You would remove the wires, first thing. And once you remove the wires, you also want to eliminate the controller, so remove the controller. Already looks very clean, right? So all the wires, all the controllers are gone. Now you need to make this system work, right? So what we came up with is a local wiring system where the reader connects to a power locally sourced. Typically, power is easily available at every door. When you have lights, you have power. It's very easy to convert AC down to DC right at the door. It's not a big deal. You can have everything connected right near the door. So the amount of wiring is reduced by huge amounts. Instead of running, say, 100 miles of cable, you're running few feet of cable. Right? Now, the whole system would work locally here, but now you need connectivity, right? You need to be able to enable permissions on the reader. And that is where the mesh comes in. So we install a gateway device in the building, which can now connect to all the readers over a mesh network. So more the doors, better is the mesh network. And now you can, using a web-based application, just manage your entire access control system. You can also give local control directly at the gateway by opening an interface on the gateway and have a local machine talking to the gateway, or you can do it cloud-based. But what this has done is eliminated a huge amount of hardware and wiring from the buildings. So to achieve this, we had a few choices, right, in terms of what technology to use when we started out. I used to work for Broadcom, so I was very familiar with Wi-Fi. We were a Wi-Fi company, and Bluetooth. So these were the two things we were considering, but Zigbee was the one we actually first considered, because Zigbee was very strong in lighting automation and had a good presence in a lot of products. But we didn't end up selecting Zigbee just for the reason is smartphones didn't have Zigbee. So we wanted the smartphone to be communicating with the devices, especially to open doors, right? So Bluetooth was the choice when it came to opening the doors. So Zigbee was out because of that reason. Wi-Fi was obviously the obvious choice, because Wi-Fi actually is very easy to develop an application on it. You don't have to figure out anything in terms of the communication layer of it. But the basic problem with Wi-Fi was obviously power. We knew that there would be devices on battery running in access control, like door locks, which would need long battery life. So Wi-Fi was not suitable for that. And also, when you're doing a large scale building deployment, it's very hard to get on a building Wi-Fi network when it comes to IT. There is a thing between IT and security. IT guys don't like devices coming on their network. Right? So we needed an independent network, which would not be under the IT. Then the last two choices are Bluetooth and Thread. When we started the company, it was 2017, end of 2017, and we couldn't get great resources available at that point of time for Thread to implement a Thread network, and we went with Bluetooth. Now, obviously, maybe I was biased from my Broadcom background on Bluetooth. And so we went with Bluetooth at that point of time. These are the key reasons. We got good libraries from silicon vendors. Bluetooth Mesh as a standard was released in November 2017. Smartphones had Bluetooth. That was one of the key things. Smartphones talking to the devices was very key for us. Now Thread does allow to switch between Bluetooth and Thread multi-protocol for some time, but we were not aware at that point of time. And silicon vendors had very good support when it came to implementing Bluetooth Mesh. And obviously it met our requirements of low power, mesh, multi-hop, and whatever we needed to do. Until we started scaling, when we started seeing some issues with scaling and interoperability. So here is a comparison from our point of view, what mattered to us between Bluetooth mesh and thread, which led to us considering thread as a protocol for our devices. Bluetooth mesh, although it's a mesh network, it is more focused on smaller networks. You saw that would not scale to thousands of nodes seamlessly. So home automation was a very good market for, very good market for Bluetooth mesh. We see a lot of focus in thread on commercial buildings. Right? IP became a big factor for us. Bluetooth mesh doesn't support IP, whereas thread supports IP, and that allows application layer agnostic behavior for a network. Right? So that's the next point where we don't have to worry about application layers when you have IP connectivity with devices. Anybody can build an application layer just using IP addresses, and that opens up a whole world of interoperability between different software vendors and hardware devices. On the routing side, Bluetooth mesh does manage flooding, whereas thread is a routing network. So when we implemented Bluetooth mesh on a large network, to manage the routing of the packets, we had to write additional layers on top of it. Bluetooth mesh has this concept of time to live and caching, and that's not managed by the mesh protocol itself. You have to manage it yourself depending on the size of the network. So we had to write a lot of layers on top of it so that the network would work and to make sure that the packets really reach the destination. We had to write our own acknowledgement layers to make sure that the packets made it. And what that resulted in increased latency. Right? In a big network, Bluetooth mesh has higher latencies, and that's been observed in our own networks, where packets take few hundreds of milliseconds to make it to the end destination. Whereas with thread, we get pretty consistent latencies for multiple hops, and even irrespective of the payload sizes. And finally, the ecosystem, which is there around Bluetooth mesh versus thread. We were betting that Bluetooth mesh really would get an ecosystem which would develop it into an interoperable standard. Whereas, over the last 4 years, thread has done really well in terms of building an ecosystem of companies around it to kind of make it open and interoperable. And I think that is very key for any new product which goes into the market. It needs to become an interoperable standard for access control, right? And that is what we are headed towards. So interoperability is key for us. Now, today, the system is interoperable. The way it is interoperable is using the vegan protocol. Every reader supports vegan. Every controller understands vegan. So when a card is swiped, it sends the 26-bit number, which any controller can recognize. So that's interoperability. And from the controller, it is LAN, right? But if our goal is to reduce the amount of hardware and wiring, interoperability needs to come between readers and the border router or the gateway device, right? Which means we should be able to deploy readers from different manufacturers and a gateway device from another manufacturer in the same building, and they should just interoperate. Now, this network is a thread network. Obviously, thread is application layer agnostic, but at application layer, there needs to be interoperability, right? So probably I'll have a discussion with a few of you guys on the application layer side, where how can readers understand each other when they talk over a wireless mesh network, because we pretty much eliminated the need for vegan here. The card reader understands vegan by themselves, right? So you read ID, it compares right there. You don't have to send vegan anywhere else now. Now you have to understand some other language about how to give permissions to user, how to set up schedules on the door. There is no standard right now for that. Probably that is out of the scope of thread, but probably at an application layer, we have to figure out how to standardize them. So we are focused on access control, but obviously we exist in a building which consists of other systems. So we believe that all these systems will be talking to each other over the mesh network seamlessly, and a network would our access control devices would support or basically strengthen the network. So when new lights come in, with thread connectivity, our access control devices would just help them out instead of interfering with them, right? So when new devices come into the building, the whole network should work in sync to strengthen the network. More the devices, better is the network, right? And that will only happen if they understand each other's language, which is the thread protocol which they will support. One of the key things which we considered when we moved to thread is IP Bliss, where thread is part of the alliance, which allows buildings with existing systems like BACnet or KNX to also work with wireless thread devices. And that was key for us because we would go into buildings which have systems already in place and we need to retrofit them to make them wireless. So the IP Bliss Alliance is key for the future of building automation. And we are very keen to collaborate in this space and try and come up with standards which will allow access control systems to work with each other, and also in future access control devices to work with other devices in the building, which like lighting or HVAC systems. Thanks. I'd be happy to have any questions on access control or any other aspects of building automation.
Questions? I guess.
Okay, there's a question.
Oh.
Just one there. What's your report on potential security issues if all the devices could be picked up in one large mesh network?
I think the protocol should take care of the security because there are application layer keys, right? So although at the thread layer they are talking with each other, I think they may be running on different application layers. So the application key should protect the application specific data, right? I mean, I'm guessing that's the answer from application point of view.
Cool.
Yeah, thank you.
So Rohin, I guess I had one question. So you went through the process of looking at Bluetooth mesh. Obviously, your initial products were Bluetooth mesh. Can you guys hear me? Okay. I guess at what point, like in terms of scale, can you give us some numbers around at what point you felt like this is you have to add lots of additional capabilities in the protocol to make it reliable?
Yeah, so we were doing a deployment of about 150 readers in a building, which is 5 floors over a mesh network. There were customers complaining that we enabled permission on a particular device, door, and the card is not working, right? Mm-hmm. Obviously, the packet did not make it through, and we did not have acknowledgements, our level of acknowledgements implemented at that point of time. It was the mesh acknowledgement which was there. So we then added our own acknowledgement layers, which caused huge latencies for the things to get through the network to the devices.
Yeah. Great.
Yep.
So you had some experience, rolling thread out into those, and can you speak to how it's done?
So at this point, thread is not, we have not commercialized the thread products yet. We have demos working. We have done testing of about 40 devices in a network for thread, and we've measured latencies, pretty consistent when it comes to performance. Our rollouts will start in June this year.
My question was related. I wasn't sure whether you transition. My question was, what was your experience transitioning your shipping Bluetooth mesh products to thread? And I would imagine that it's all new hardware. So that sounds like you have it actually.
Actually, it's not all new hardware. Actually, our new products will have support for Bluetooth mesh and thread both. We can configure it during the deployment, whether you want to go with mesh or thread. So the new hardware will be compatible with both protocols.
So I guess that that inspires a follow-on. What describe the planning around doing an in-field upgrade or how you're gonna go about transitioning product in the field from Bluetooth mesh to thread?
Some of our current products will not be able to move to thread because they don't have the right silicon or hardware which is required. But we will be able to deploy our existing hardware in a Bluetooth mesh network and set it up as a Bluetooth mesh. For upgrades for that hardware to go to thread, we can do over-the-air upgrades and transition the entire network from mesh to thread, as long as the hardware is compatible with thread.
All right. Thank you, Rohin.
Thank you very much.